The final way in which we can combine two functions is to divide one by the other. Here, we will look at how to compute the derivative of g of x divided by h of x. If we're in the case where our function f of x can be written as a fraction g of x over h of x, how do we compute its derivative? We will now find this derivative without going back to our definition of derivative. The way we will do this is by multiplying f of x, which is g of x over h of x, by h of x. Now on the left, we have h of x times f of x, but on the right, we simply have g of x. The reason this is useful is because now we have a product of two functions, and we can compute the derivative of g using the product rule to get that g prime of x equals h prime of x times f of x plus h of x times f prime of x. What we are looking for here is f prime of x. So we need to solve g prime of x equals h prime of x times f of x plus h of x times f prime of x for f prime of x. We'll start by subtracting h prime of x times f of x from both sides, and then dividing both sides by h of x to get that f prime of x equals g prime of x divided by h of x minus h prime of x times f of x. However, we would like to put this all in terms of our functions g and h. So we need to replace f of x with g of x divided by h of x. Unfortunately, we now have a compound fraction, that is, a fraction within a fraction. So we'd like to simplify this. In order to simplify this, we want to multiply the top and bottom of the right-hand fraction by h of x. That way, up top, we're left with h prime of x times g of x, and down bottom, we have h of x squared. But now that we don't have a compound fraction, we're left with two fractions with different denominators. To resolve this, we'll multiply the top and bottom of the left-hand fraction by h of x to get g prime of x times h of x up top and h of x squared down bottom. Notice that both of our fractions now have the same denominator of h of x squared. So we can subtract one fraction from the other by simply subtracting the top of one fraction from the other to get f prime of x equals g prime of x times h of x minus h prime of x times g of x all over h of x squared. This is our final form of the derivative of g of x over h of x. While it's the messiest of all of our derivative formulas, it's actually the easiest to use because it's so easy to tell what our functions g of x and h of x are when we have a fraction. So we have that the derivative of a function g of x divided by h of x is g prime of x times h of x minus g of x times h prime of x all divided by h of x squared. We will refer to this as the quotient rule, and we can use it to compute the derivative of e to the x over x. As stated before, it's easy to see when we have a quotient of functions, and it's easy to tell what our top function g of x is and what our bottom function h of x is. Here we have that g of x is e to the x and h of x is simply x. Now, in order to compute the derivative of e to the x over x, we need to compute the derivative of e to the x, which is e to the x, and the derivative of x, which is 1. Using our quotient rule, we have that the derivative of e to the x divided by x equals e to the x times x minus e to the x times 1 all over x squared. which we can rewrite as x times e to the x minus e to the x all over x squared. It's worth pointing out that here we use the quotient rule to compute the derivative of e to the x over x as x times e to the x minus e to the x all over x squared. However, we looked at this previously using the product rule, except we wrote e to the x over x as e to the x times 1 over x. In both cases, we found the derivative to be x times e to the x minus e to the x all over x squared. The reason this is worth pointing out is because in many examples, we can compute the derivative in two different ways and get the same result. Let's use the quotient rule again to compute the derivative of one more function, which is x squared over 2 to the x. Here, we have our numerator is x squared and our denominator is 2 to the x. So we need to compute the derivative of the numerator, which is the derivative of x squared, or 2x, and the derivative of the denominator, which is the derivative of 2 to the x, which is the natural log of 2 times 2 to the x. Putting this together using the quotient rule, we have that the derivative of x squared over 2 to the x is 2x times 2 to the x minus x squared times the natural log of 2 times 2 to the x all over 2 to the x squared. While there are some simplifications we can do, it is perfectly alright to leave our final answer in this form.